Hello and welcome to Brendan Explains Scientific Concepts Regarding Agriculture. I know it's a temp name. Let's start with the first episode of whatever this will be called. Let me know what name I should use in the comments section below. Before we begin, we have to establish some terms, because the terms in science, such as theory, mean very different things than in common parlance. For instance, in more common speech, theory means educated guess. In scientific terms, this would be closer to a hypothesis. A hypothesis is a falsifiable model that explains a specific phenomenon and can be described in a if this then statement. It's the idea that's tested against reality. A theory is a well-tested and well-documented model that can be used to predict future events related to a specific phenomena and explains current events within a specific phenomena. One example of a well-known that stood the test of time is germ theory. This is the highest point in science. Theories do not graduate into laws. A law is just a general phenomena that is observed consistently within a series of specific events, and can often be represented mathematically, such as the law of gravity and Boyle's law. Laws are used as parts of hypotheses and theories, alongside other data points, but are not theories or hypotheses in themselves. To understand the full scientific method, let's use a hypothetical example. Let's just say you're a researcher who's growing a lot of cherry trees, specifically Bing cherry. You find that one year, brown rot has taken out most of your cherries, but you found one branch that didn't have any brown rot on it. Out of curiosity, the researcher snips off the branch and looks through it using the microscope. He finds a great many common bacteria species that he knows of, but one that he does not know of. After comparing those bacteria types against their known capabilities, he discounts that any of the strains or species of bacteria that he knows of are responsible for preventing brown rot in his cherry trees, leaving that unknown bacteria the most likely possible candidate for the prevention of brown rot on that one branch. So this researcher, being a smart microbiologist, cultures both the brown rot and mystery bacteria on petri dishes, and later create another petri dish where both can be grown on at the same time to see what happens. The researcher observes that this mystery bacteria secretes a strange chemical that seems to kill off the fungi. He samples the secretion and finds that it's a combination of three chemicals A, B, C, but he also observes that the growth rate of the bacteria is faster than the fungi. So he creates two hypotheses on what might be the primary cause of the loss of brown mold on that branch of the cherry tree: the competition hypothesis and the chemical ABC hypothesis. Did the mold fail to grow because there's simply no room for the mold to grow on? Or is it because the biochemicals released by the bacteria are that deadly to the fungus? This leads to the researcher creating an experiment to test out this hypothesis. In this experiment, the hypothetical researcher tests these two hypotheses by obtaining large plots of land and getting 12 well-spaced apart groups of plants, specifically Bing cherry trees, all on the same rootstock and all on the same soil. By not being grown with anything sprayed on it, 3 strips are sprayed with a common fungicide like Captain, 3 more strips are sprayed with the bacteria, and 3 more strips are sprayed with the 3 chemicals. He finishes the experiment using 3 trials, calculates the consequences, and analyzes the results using statistics to come to a conclusion. This is then sent to peer review, where other like-minded researchers test that hypothesis out and look for any problems in the methodology. If it gets accepted, then it becomes a theory. Is this theory proved right? No. It is simply a provisional model on how this event happened. I'll let Feynman explain.
Any definite theory wrong. Notice, however, we never prove it right. Suppose that you invent a good guess, calculate the consequences, and discover that every consequence that you calculate agrees with experiment. The theory is then right? No, it is simply not proved wrong. Because in the future, there could be a wider range of experiments, you can compute a wider range of consequences, and you may discover then that the thing is wrong. That's why laws like Newton's laws for the motion of planets last such a long time. He guessed the law of gravitation, calculated all the kinds of consequences for the solar system and so on, compared them to experiment, and it took several hundred years before the slight error of the motion of Mercury was developed. During all that time, the theory had been failed to be proved wrong and could be taken to be temporarily right, but it can never be proved right because tomorrow's experiment may succeed in proving what you thought was right wrong. So we never are right, we can only be sure we're wrong. However, it's rather remarkable that we can last so long. And
as you can see, the theory can only be failed to be proven wrong, but never proven right. And as time goes on, other models may show up that might disprove the hypothesis. One researcher may come up with an idea that one specific chemical is the primary active ingredient within the free chemicals. If the free chemical hypothesis is shown to be the most likely outcome, and many other hypotheses and models could be made just off the top of many people's heads when it comes to this hypothetical scenario. In science, all theories are provisional and subject to edit or rejection if the evidence turns against them. Well, that about covers everything. Thank you for watching. Thank you for watching this video. If you're watching on YouTube, please subscribe to me on BitChute for a greater variety of content, 4 videos a week. And thank you to all my subscribers on both platforms. I appreciate it.